The lesson outcome for this video is write equations of lines from a graph. We've been doing a lot of writing equations for lines given different information, and now what we will be given is a graph, and then we need to write the equation for that line. So on this coordinate plane here you see a line, and there are actually two different forms of linear equations that you could use right now to write your equation. So one of them is you could use slope-intercept form. Okay, so for slope-intercept form, we remember, hopefully, right, everybody, that y equals mx plus b is our general form for that equation. M is our slope and b is our y-intercept. So we're going to start by writing this equation by finding both of those values. M equals and b equals. So if we look at this graph, what we want to do here is find a couple different points on the line that we can use. So let's find a couple points. Let's see here. One of the points that you're going to want to probably use is the y-intercept. That's going to be handy. That one's right on 3. And then another point on the line is this point right here, and I use that one because it's right where 5 and 7 intersect on the x and y axis. You could have used any points. These are just the 2 points I chose to use. So now, to write my slope, I'm going to count my slope, rise. Let's see, where's my little cursor here? I'm going to count 1, 2, 3, 4 up, and 1, 2, 3, 4, 5 to the right. So I've gone up 4 and right 5, so my slope is 4/5. My y-intercept, as we already determined, is right here, and that's where y is 3. So our y-intercept is 3. So now we can write the equation for this line, which we've actually done in slope-intercept form before. Y equals 4/5 x plus 3. So that's one method that we can use to solve or to write the equation of this line. Now, the second way we can do this is by using point-slope form, which we've just recently been starting to use in class. So point-slope form, you'll remember, is y minus y1 equals m times x minus x1. So what we'll need to find in order to write this equation is we'll need to find again m, the slope, and we will need to use our x1 and our y1 to write down a point that is on this line. Okay, so first of all, we already found our slope by doing the first example with slope-intercept form, so I'm not going to count it out again, but we did count out that it was up 4, right 5, so 4/5. Now, what we need to do next is find our point x1 and y1. What I'm going to use is I'm going to use this point right here. We've already put it on our graph, so if I just name this now 5, 4, and again it's 5, 4 because here's 5 on the x-axis. Oh, sorry, let's back up. Let's erase that. It is not 5, 4. My bad. I apologize. Hopefully you caught on to that. It is 5, 7. Oops. So right here is 7 on the y-axis. So 5 on the x-axis right here meets up with 7 on the y-axis right here to give us that point 5, 7. So our point 5, 7 tells us that our x1 is 5 and our y1 is 7. So now to write this equation in point-slope form, we're going to write y, and then what goes next to this, remember, is our y1. Well, our y1 is 7. Okay, so we're going to write y minus 7 equals 4/5, which is our slope, and then x minus our x1. Remember, this is our x1, and this is our y1, because that's what we just got from our graph from that point that we chose. So x1 is 5, so that's going to go right here. So this also is the equation for that line. This one is in slope-intercept form, and this one is in point-slope form, but they are exactly the same line. Okay, let's try a second example. The first thing you might notice about this purple line on this coordinate plane is that we can't really read the y-intercept from the coordinate plane. Notice that somewhere down in this region, our line would come through and hit our y-axis. So because of that, think about for a minute, which form would we probably not be using? Okay, well, we probably would not be using y equals mx plus b, because in order to use y equals mx plus b, we would need to know the y-intercept. And we would have to estimate it, and that's not the best plan. So let's not use this form. Let's go ahead and write this equation in point-slope form, which is another reason why this is a really handy method of writing equations of lines. We can always find the slope, and we can always find a point on the line. So again, if this is called point-slope form, it is because we can easily find a point and the slope and write it in our equation. So let's find a point and let's find our slope. All right, so to find our slope, I'm actually going to start with that. To find our slope, we need 2 points somewhere on this line. Again, it doesn't matter where, just as long as, again, we're looking for pretty much whole number intersections for our points. So the first one that I kind of notice is, let's see here, this one right here. That's pretty much right on -5, -1. And another point that I notice is right here where, pardon me, where -7, 4 exists. So I'm going to go ahead and write those points down. Again, this first point here is at -5 on the x-axis and -1 on the y-axis. So I'll write -5, -1. This point up here, right, this one, is at -7, 4. -7, 4. Now remember, you have to be really careful when you're writing your points so that you don't make mistakes with that. Okay, so then to find our slope, we're going to count our rise and our run. Remember, once again, like usual, it does not matter if I rise from this point and run to this point, or if I rise from this point and run to this point. Either way, we will have the same answer. So let's go from here. We go down 1, 2, 3, 4, 5, down 5, and right 1, 2. Down 5, and right 2. A point on this line. Again, it doesn't matter which point you choose. You can choose -7, 4, or you can choose -5, -1. It doesn't matter. So I'm going to choose -7, 4. So now we're going to write the equation, looks like this, by putting in our x1 and our y1 and our slope. So y minus y1, y1 is 4, equals our slope, -5/2, times x, and then here's our x1 is -7, so x minus -7, minus -7. Be careful with that. So when it's all said and done, we can simplify just a little bit. Y minus 4 equals -5/2, x minus a -7 is +7. You'll probably remember that we talked about how when this number here is -7, when you put it in the equation, it looks like +7. It is +7 in the equation. And when we've got y1 as 4, we put it as -4. Okay, this is the equation for that line. Okay, try these two examples. Pause the video and then try these two examples, and then I'll come back and I'll let you know what the equation should be for the blue line and the pink line. One thing I will let you know is that I will use the 2 points on each line that are provided with dots. You could write the equation for these lines with a different point if you chose a different point, but for the sake of checking your work, go ahead and use those dots that I provided. Okay, so to start with the blue line here, we've got 5, 1 is this point, and this point over here is 8, -5. It's a negative sign there. Okay, negative, not positive, that's a negative, okay? So, the equation for the blue line will be y minus y1 equals m times x minus x1. The slope, if I count the slope here, I'm going from this point right here, 1, 2, 3, 4, 5, 6 down, and 1, 2, 3 right. 6 down and 3 right. Your slope should be a negative, and it should be -2 when simplified. When we put the point in here, I'm going to just go ahead and use this point here. If you use the other point, your answer will be a little different. I'm going to put 1 in for my, again, this is my x1 and my y1. I'm going to go ahead and put 1 in, so -1. Again, if this looks positive, it'll be negative in the equation. And then x minus 5. So y minus 1 equals -2x minus 5. Okay, the other one, the pink equation, this point here is 1, 5, 1, 5. And this point over here is -4, 2. So we find our slope by counting up 1, 2, 3 and right 1, 2, 3, 4, 5. So our slope will go in for m, and we counted, sorry, I forgot already. So 3 over 1, 2, 3 over 5. 3 over 5, up 3, right 5. And we've got something to fill in there for x1, and we have something to fill in over here for y1. I'm going to pick this point this time, use this for my x1, use this for my y1. So I have y minus 2, and I have x minus -4. If you right away wrote that as +4, that is fine. Here's our equation. One last question. Which of these two lines, blue or pink, could you have written also in slope-intercept form? The answer is the pink one. Again, the blue line, we can't tell where that's intersecting the y-axis right there for our y-intercept. For our pink line, we could have estimated this point right here for our y-intercept, and we could have written it in y equals mx plus b form.